Welcome to True Projects. In this video, we are going to explain about the project titled Asthma Disease Prediction using Deep Learning and Machine Learning. Before diving into the execution, let me give you an overview of the project. Let us first understand what asthma is. Asthma is a lung condition that makes it hard to breathe. When someone has asthma, their airways get swollen and narrow, making it tough for air to move in and out of the lungs. This can cause symptoms like coughing, wheezing, chest tightness, and feeling short of breath. Things like allergies, cold air, exercise, or smoke can make asthma symptoms worse. People with asthma often use inhalers to help them breathe better. It's important for them to work with doctors to find out what triggers their asthma and how to manage it effectively so they can live a normal, healthy life. In this project, we aim to create a system using machine learning and deep learning algorithms to predict when someone might develop asthma or experience worsened symptoms. Traditional methods for asthma prediction include statistical analysis, logistic regression, and random forest. But these traditional methods have some limitations, which include their inability to capture the full complexity and nonlinear relationships in asthma datasets, often relying on simplistic assumptions and predefined rules that may not reflect the true patterns within the data. In the waste paper, the author has proposed multiple machine learning algorithms, including decision tree, MLP-ANN, that is multi-layer perceptron artificial neural network, and deep learning techniques like convolutional neural network CNN and CNN plus LSTM for asthma prediction, aiming to improve early detection, personalized treatment, and proactive management to enhance patient outcome. To further enhance the performance of asthma prediction, we have proposed ADA Boost, bagging classifier, and voting classifier. These methods combine multiple models to enhance accuracy and robustness. Integrating these techniques can improve the model's generalization and overall performance. The project predicts asthma diagnosis using symptoms like tiredness, dry cough, difficulty in breathing, sore throat, pains, runny nose, and demographic factors like age range, gender has input features. The project evaluated algorithms using metrics like accuracy, precision, recall, and FN score to determine their effectiveness in predicting asthma diagnosis accurately. The project benefits individuals with asthma, healthcare providers, public health authorities, and researchers by improving asthma management through early detection, personalized treatment plans, targeted interventions, and research insights. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms built in the project. The first 4 algorithms are proposed in the paper, and the last 3 algorithms are proposed by us. We have built these 4 algorithms to compare with the proposed algorithms to show how effectively our proposed algorithms are performing. So out of these 3 algorithms, voting classifier performs well. That is the reason we have deployed this voting classifier in the front end. Now let us understand what voting classifier is. The voting classifier combines predictions from two base models, a bagging classifier with a random forest base model and a standalone decision tree classifier. During prediction, the voting classifier considers the predictions of both models and aggregates them using a soft voting approach, which takes into account the probability estimates from each classifier. This ensemble technique aims to improve the overall accuracy and performance of the model by leveraging the diverse perspectives of the individual base model. To execute this project, first we need to open the code folder. So here we have the project source code files. Let us discuss each of the file. So this is a static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the data set. This is the data set. So here we have the symptoms of asthma, which are tiredness, dry cough, difficulty in breathing, sore throat, non-symptom, pains, nasal congestion, runny nose, non-experiencing. And here we have the age ranges from that is 0 to 9, 10 to 19, 20 to 24, 25 to 59, and 60 plus. And here we have the gender, female or male. And here we have the severity, mild, moderate, and none. So this data set will be pre-processed and then used to train and test the models. This is the sample data set after pre-processing, which we will use during the execution. So here, these are the symptoms of the asthma disease. And here we have the label that whether the patient is diagnosed with asthma or not. This is signup.db file. This file is the database file used to store user information. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered, so click on sign in. Here we need to enter the username and the password, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to enter these values to predict whether asthma is diagnosed or not. Tiredness is 1. It means that the person is tired. Dry cough is 0. That is, the person is not having the dry cough. Difficulty in breathing, 0. Sore throat, 0. None symptom is also 0. Pains, 0. Nasal congestion, 0. Runny nose, 0. None experiencing, 0. So here, 0 means that the person is not suffering with that symptom, and 1 means the person is suffering with that symptom. So here, these all are the symptoms of asthma, and the age range is 25 to 59, and the gender is male. Now click on predict button. So here we can see the result. The patient is diagnosed with asthma based on the input. Now let us enter another set of parameters. Click on prediction link here. So here the tiredness is 0. Dry cough is 0. Difficulty in breathing 1. Sore throat 1. None symptom 0. Pains 1. Nasal congestion 0. Runny nose 0. None experiencing 0. Age range is 10 to 19. Gender is male. So here 1 means the person is suffering with the symptom. 0 means the person is not suffering with the symptom. After entering all the values, click on predict button. So here we can see the result. The patient is diagnosed with asthma based on the input. Let us enter another set of parameters. Click on prediction link. So here the tiredness is 0. That is, the person is not tired. Dry cough is 0. Difficulty in breathing 1. That is, the person is facing difficulty in breathing. Sore throat 1. None symptom 0. Pains 0. Nasal congestion 1. Runny nose 0. None experiencing 0. Age is 20 to 24. Gender is female. Now click on predict button. So here we can see the result. The patient is diagnosed with asthma based on the input. Now again click on prediction link. Let us enter another set of parameters from the sample data set, which I have showed you earlier in the code folders content. So here the tiredness is 1, dry cough is 0, difficulty in breathing is also 0, sore throat 0, none symptom is also 0, pains is 1, nasal congestion is 0, runny nose 0, none experiencing is also 0. 0 means the person is not suffering with the symptom. 1 means the person is suffering with the symptom. Age range is 60 plus. Gender is female. Now click on predict button. So here we can see the result. The patient is diagnosed with asthma based on the input. So in this way, just by entering the features, we can predict whether the patient is diagnosed with asthma or not. Now click on graph link. So here, this is the sample outcome graph, which displays the distribution of labels. Here on the x-axis, we have the different labels, that is yes and no, and on the y-axis we have the count for the label. So here we can see that the yes label is having the more count compared to the no, and here we have the age range graph. On the x-axis we have the different age groups, that is 10 to 19, 20 to 24, 0 to 9, 25 to 59, and 60 plus. And on the y-axis we have the count for those age groups. And these are the comparison graphs with the evaluation metrics: accuracy, precision, recall, and F1 score. So here on the x-axis we have the accuracy score, and on the y-axis we have the algorithm name. Accuracy is a measure of the overall correctness of a classification model. It represents the proportion of correctly classified instances among all instances evaluated. And this is the precision comparison graph. Here on the x-axis we have the precision score, and on the y-axis we have the algorithm name. Precision is a measure of the correctness of positive predictions made by a classifier. This is the recall comparison graph. On the x-axis we have recall score, and on the y-axis we have the algorithm name. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a data set. This is F1 comparison graph. On the x-axis we have F1 score, and on the y-axis we have the algorithm name. F1 score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. The algorithm which is performing best will be used for prediction. So here the voting classifier is performing best among all the other algorithms. That is the reason it is deployed in the front end.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.